Hi folks, this is a paper from the Kilodegree Survey collaboration, KIDS, and it's a study of massive elliptical galaxies, like these here in the background. These galaxies make for a very homogeneous population, but there is diversity among them. Some of these galaxies are larger than others, and although they're all red, some are redder than others. What is the origin of this diversity? The first thing to look at to answer this question is their halo mass. This is because the dark matter halo plays a major role in determining the evolution of these galaxies. And so we looked at KIDS weak lensing data to see how halo mass varies with size and color. Now, usually when we do these kinds of measurements, we measure things at fixed stellar mass. But we've reached the point where errors on the stellar mass measurements, especially systematic errors, end up dominating the budget. And so we took a step back and measured things at fixed luminosity instead. We'll leave it up to theorists to predict luminosities for their models. Here's the stacked weak lensing signal for the galaxies in our sample, split according to size and color. Now, this is just for illustration purposes. The actual analysis was done with the Bayesian hierarchical approach, but the main thing is that we didn't see much of a variation in halo mass with either of these quantities, so we could only put an upper limit on the strength of these correlations. Now, one could say, but how confident are you in your size measurements? Because we define sizes by fitting surface profiles, but what if the true surface brightness profile of these galaxies is not surface? So we repeated the analysis with a more robust description of the surface brightness distribution, and basically we found the same result. Halo mass does not correlate strongly with color. What we learned from all this is that although halo mass is very important, it doesn't determine everything. So things like the size or the color of a massive elliptical galaxies probably depend on other features. Thank you for watching.